Hello, good morning everyone. Today we will discuss about the topic motion. So it is in ninth standard, chapter 8, Cbse. So motion. So whenever this term comes in front of us, we always pick up the ideas of moving objects. So whenever we see an object moving, we can say the object is in motion. So picking up some examples, so we can say the vehicles which are moving on the road, and then the birds flying in the sky, the wind blowing. All these are examples of objects in motion, or we can say moving things. Then the other state of motion is rest. So when do we say an object or a body is at rest? So when they remain stationary in the sense they do not change their position. So picking up some examples, we can say the rocks are stationary, the buildings are stationary, the trees are stationary. So these are some of the examples which are at rest. Now, to have some more clear idea about the concepts of rest and motion, let me pick this example. So I am going to explain this with an example. Please bear with me. Okay. So in this example, so we are seeing a tree and a railway compartment. So this should be the direction of motion. If the rest of the train is not there in this picture, so this is moving in this direction. So I have taken one tree. We see many trees and greenery outside, many number of fields, large number of fields. So when the train is moving, so I have taken one man standing under the tree outside, and the train is moving in this direction. You are sitting somewhere inside the train near the window. Now, for this man who is outside, so the train and you appear to be in motion. So, from man's point of view, you are in motion, but you are sitting inside the train. So, with respect to the interior, the fans, the seats, and the co-passengers. So, with respect to the interior of the train, since you are not moving, you are sitting, you are at rest. So, this person, that means you, with reference or with respect to this man, you are in motion. At the same time, with reference to the interior of the compartment, you are at rest. So whenever we are defining the state of rest or of uniform motion or motion, so a reference is very much important with reference to a particular object. Generally, for reference, we are going to consider a stationary object somewhere in the surroundings. A stationary object, we are going to take it in the surroundings, and with reference to that object we are going to point out whether a particular body is in state of rest or in motion. Let me pick one more example for you to understand the definitions and the topics in motion. So from this example, so I'll explain you this. So this is your house and that is your school. So let me draw the road. So you are going to move to the school from home. So this is the road. This is the road. So you have started from your house. So you start from your house at generally we go to school at 8 a.m. in the morning. So you start from your house at 8 a.m. Let your house be position 1. So at 8 a.m. maybe bus and the school bus. You board on the school bus and you started moving. So by 8:20 a.m. you reach the school. So, so the school, let me say the school as position 2. So this is position 1. So whenever we say an object is in motion, definitely there is a change in position. So there is a change in position with time, with the time. That means at 8 a.m. you are at home. As the time keep on ticking, your position also keep changing. From your house you started moving. So this is a small example to define or to have a clear idea of the definition of motion. So we can define motion as an object is said to be in motion if it changes its position. So it is going to change its position with the time and with reference to its surroundings or with respect to its surroundings. So I'm going to put this definition in front of you so that you can have some idea, and let me read that. So an object is said to be in motion if it changes its position with the time with respect to its surroundings. Now if it is Sunday and at 8 a.m. you are at home, and even at 8:20 a.m. you will be at home, you will be sitting somewhere or sleeping on the bed by that time. So rest is nothing but if an object does not change its position with the time with respect to its surroundings, then that object is said to be at rest. So one more concept, let me tell you. Rest and motion are relative. So they are rest and motion are relative. Related in the sense, so an object may be in motion with respect to one body, at the same time it may be at rest with respect to some other body. That means at 8 a.m. let us suppose your parents are at home. So when your parents are at home, you board in the bus at 8 a.m. from house, you started moving. So for your parents, so from your parents point of view, taking them as a reference point, you are moving along with the bus, so you are in motion. But when you got into the bus, so with respect to the interior of the bus, you sat inside the bus and you are not moving, so you are sitting on a seat along with your friend. So with respect to any interior of the bus, you are at rest. So the rest and motion are relative terms. So with reference to or in relation to a particular object, a body may be at rest. At the same time, it may be in motion. Let me give one more example. That is, on the earth, we stay in our house sitting somewhere and watching some videos at home. So we feel that we are at rest. But for a person who is watching from the moon, since the earth is rotating as well as revolving, for that particular person, so you are in motion. That means your position keeps on continuously changing along with the motion of the earth. So rest and motion are always relative terms. Now we'll go for the next topic. In order to understand or in order to have some idea about distance and displacement, there is an important difference between the physical quantities which we know. So physical quantities generally are those quantities which are measurable. Physical quantities are measurable and which obeys the laws of physics. So such quantities are called physical quantities, just like time, temperature, velocity, force, current. These are all physical quantities. So physical quantities are two types: scalar quantities, and on the other hand we have vector quantities. So what is a scalar quantity? For a scalar quantity, to define or to describe a particular quantity, just the magnitude is sufficient. Magnitude is sufficient. Magnitude in the sense you will have the numerical value of that physical quantity along with the unit for that physical quantity. So generally we consider magnitude as the numerical value, but since it's a physical quantity, so a numerical value plus the unit together is sufficient for describing that and that quantity. So let me give you this example. So present, generally in physics we take the room temperature as 25 degrees Celsius. Now 25 is the magnitude Degrees Celsius is the unit for that physical quantity. Since this is sufficient to have the complete knowledge about the temperature, so it's a scalar quantity. And then what is the current flowing in the wire? So the current flowing in the wire is 10 amperes. That is sufficient. The amount of current along with the unit. What is the voltage? The potential difference 220 volts. So numerical value along with the unit. So these are all these quantities come under the scalars. So then what is the vector quantity? So vector quantities require, for their complete definition, they require the magnitude along with direction. So those quantities which are described by defining both magnitude as well as direction. So for this I am going to pick a small example. So this one is a mass kept on a floor. Now I want the mass to move this direction. In order to make this to move in this direction, I need to apply some force. So force, and since my aim is to make it move in this direction, so I'm going to apply the force towards the east direction. So 100 newtons of force. This will be the magnitude of the force along with the direction. So force comes as a vector quantity. So magnitude as well as direction. So we also observe this when a person is standing on a weighing machine. Generally we'll keep the weighing machine below and we'll stand on the weighing machine. We don't lift the weighing machine, so we always keep it down. Reason, we are weight, so the person's weight is always acting downwards towards the center of the earth, so that in order to measure the weight, so you need to stand vertically upright on the weighing machine. So weight is a vector quantity, nothing but a force. So then we have another quantity, velocity, that is speed along with direction is velocity. Acceleration, okay, then you have displacement. As we go through this lesson, you will have some, as we cover some topics in physics, you will understand the scalars and vector quantities and know the definitions of velocity and acceleration in an easy manner. Let me put this differences in front of you and quickly read out the scalar and vector quantities. So yeah, a scalar quantity, a physical quantity which is completely defined by its magnitude alone, is a scalar quantity. So example, time, temperature, work, energy, mass and speed, these all are just sufficient to be described along just with magnitude. But a vector quantity requires both magnitude and direction for its complete definition. So force, displacement, weight, torque, and velocity, momentum, etc. These all are vector quantities. So that's all for this class. So we will see about distance and displacement in the next video. Thank you.